Hi, this is Ritu, and the topic that I've selected is multimodal automated interpretability agent, in future referred as MAIA. This paper was authored by researchers in MIT CS and AI department, and these are some of the things I'll be covering in the video. Let's understand why interpretability matters. It's because AI models, as we're diving further into it, neural network especially are becoming more and more complex, which indeed is making it complex to understand how and why these models are making certain decisions. Yes, there's a need for transparency, not only for debugging or improving the accuracy, but also building the trust between the researchers as well as the users using the model. Now, some of the related work in this field involves using models like GPT-4 and Claude, which were used to explain generate the explanation for why the neurons are getting activated in a certain way or why the AI models are acting in a certain way. There's another previous work called Milan, which was a captioning model trained on the human annotations to describe the features and visual models like ResNet. Yes, this was a one step ahead, but then there are certain challenges, one of it being one-shot hypothesis generation that's involving a human expert for further analysis. And the other limitation was it was based on a limited input set and showed low precision. And that's where Maya comes into picture. So now what is Maya? Maya is an automated system which was designed to conduct a lot of interpretability tasks using vision language model like diffusion model, GPT as backbone to analyze and explain the other neural models. The goal was to automate the whole process of interpretability where we eliminate humans, and that's why it's better than the previous approaches that I spoke about. Now, how actually it works is user inputs certain things that is model component inquiry, and one of the example being I bias is present in ResNet 152 trench class. And the output that we get is text summary or a label or visualization of what actually neuron does. And between this process, what happens is Maya initializes the model using PyTorch, and there are certain things done, for example, text to image conversion, or maybe editing the images, or maybe summarizing the text in the images, and all of this done in a loop until unless we get a final output. And the vision models that we test here in this process involves ResNet, Clip, and Deno. Let's actually understand how it works with this simple demo where we're trying to analyze ResNet layer 4, unit 593. And this is a set of initial hypotheses that we have. And we select the top 10 images where the activations are higher. And here we can see that it's higher for tennis ball, and that's the output that we get. Now, based on this output, we don't come to a conclusion, but indeed for more prompts and generate images based on those prompts, and this is what we get. And here we see that the tennis ball with white background and for tennis player with the ball has higher frequency, or higher activation. And this concludes that the neuron is selective for the tennis ball with higher activation where the tennis ball is more predominant. So more such things where more such use cases were done with Maya, which can be seen in the paper as well if you want to dive more into it. Some of the other use cases were removing the bogus features. For example, in this use case, see that the background is somewhat not so useful. And here, certain neurons which were focusing more on background were removed. Thus, from 512 units, 22 units were selected, and which gave a higher accuracy, like 93% accuracy, and which was more than L1 regularization. The second use case was revealing the bias. For example, over here, you see that the activation for male carrying the beer glass is higher, whereas women carrying the beer glass is lower. So you can also look at the biases using this system. Now, it was evaluated using human expert, where Maya performed better than Milan by 73%, and Milan was just 27% agreement with the ground truth. It was also seen that the average activation value over here, average activation value, matches the human activation value, whereas Milan was slightly lower for all the models, all the vision models, and also for the synthetic neurons, uh, it was very close to the human evaluation, whereas Milan lacked that comparison. This concludes my paper. It can be said that this works best for the AI interpretability. It is automating the process and not involving humans. Where it struggles is it relies on the prompt quality and is quite expensive because we're using models like GPT. Uh, Thank you.